Assalamu alaikum. Hope you are doing fine. You would have come across this kind of device in many appliances like fan, motor, and even in water pumps. They are known as capacitor. They are available in different size based on their capacitance. Today in this video we are going to learn about them. Here I have made one simple capacitor with the help of easily available materials. It is otherwise known as Leyden Jar. It is a simple form of a capacitor. With the help of this I will explain you how a capacitor works. Now I will charge this Leyden jar. For that I make use of a PVC pipe and a woolen cloth. I rub the PVC pipe by keeping it very close to this antenna. I have rubbed 5 or 6 times. Now I will check whether it has got charged or not. For that I use an LCD display. I keep it on this antenna. You might have observed the letters displayed on this LCD. This shows that this capacitor has got charged. The charge of the capacitor, when increases, it leads to the increase in the voltage. So we can say voltage on a capacitor is directly proportional to the charge. You can also perform this experiment by rubbing the PVC pipe with the help of a tissue paper. Now I am going to charge this Leyden jar or capacitor with the help of a tissue paper. Look at it carefully. While charging the Leyden jar, care must be taken that you should not touch the antenna or the strip using the PVC pipe. Now let me check once. You would have observed the numbers displayed on this LCD. This shows that the Leyden jar has got charged. Now let me do this one more time. This time I will check the presence of charge on this with the help of a neon bulb. It is neon bulb. It is used in the indicator lamps. Now I charge this once again. I keep it. I hold one terminal in my hand and another terminal I touch to this Leyden jar. You would have observed it glows. Now I repeat it. I repeat this once again. This time for better visibility I will switch off the lamp. Look at this carefully. Now you would have observed, I will do it once again. The neon bulb glows. This shows that charge is present in it. This neon bulb is a kind of discharge tube. It has got 2 electrodes inside separated by a small distance, and the space around it is filled with the neon gas. You can also make use of this kind of LCD display removed from electronic watch. Now once again I repeat this. I charge my homemade capacitor. Now for better visibility I use this 2 tweezer. I hold this by tweezer. Now I bring it near to it. Now you would have seen the number displayed. This shows the presence of charge in the Leyden jar. Now let me show you how I have made this Leyden jar. To make this Leyden jar, I have taken this kind of plastic glass. I have covered them with aluminum foil. Then between these two aluminum foils, I placed a strip of aluminum foil of this kind, which is cut sharp. I placed one aluminum foil covered glass inside the another. Now your Leyden jar is ready. You can also make one Leyden jar using this kind of small plastic glass. Take two glasses, cover them with the aluminum foil, place one inside the another. You will get this kind of Leyden jar. Now I am going to charge this small size Leyden jar using a tissue paper. Let's see how it works. Now bring this LCD display. You would have seen it shows the letters. It represents there are charges present in this Leyden jar. As I told you earlier, the voltage in a capacitor depends on the amount of charge present in it. Now to demonstrate that, I am going to charge this Leyden jar. I rub the PVC pipe 5 times with the woolen cloth by keeping it very close to the Leyden jar. 5. Now I'll test whether it has got charged or not. Now you can see the display shows letter partially. It is due to the fact that it has got less amount of charge. That is why the display do not glow completely. Now I will discharge it by touching this two part. Discharge, do not have charge it now. Now I will charge this Leyden jar by rubbing the PVC pipe 10 times with the woolen cloth. Put here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this time I will check once again with the help of a LCD display. Now you would have observed it glows completely. Now compared to earlier, now the charge accumulated on this Leyden jar is more, and that is the reason why the voltage produced is also more. That can be seen by the total number of segments glowing. This shows that the voltage in a capacitor is directly proportional to the charge present in a capacitor. Let me provide some more information about capacitor. As I told you earlier, capacitor is nothing but a device used to store electric charges and electrical energy. Capacitance of a capacitor is measured in farad. 1 farad is a large unit. So commercially we use these 3 units to represent the capacitance of a capacitor. So the first one is microfarad. This symbol mu stands for micro. Stands for micro. 1 micro is nothing but 10 power minus 6. And N here, it is written as nanofarad. N stands for nano. Stands for nano. Nano means 10 power minus 9. That means we divide 1 by 10 power 9. And here P, it is said as picofarad. P stands for pico. Stands for pico. 1 pico is 10 power minus 12. The smallest value among them. These three units are usually used to represent the capacitance of a capacitor. And when we talk about capacitor, a capacitor consists of two metal sheets separated by a small distance. So it is represented by a symbol of this kind. See, we draw two parallel lines separated by a small distance. Here usually we represent a non-polar capacitor using this symbol. It's a non-polar capacitor. A non-polar capacitor is one which do not have polarity, plus or minus sign. And polar capacitors are represented by this symbol. We draw a straight line and another line is curved in this manner. This is the symbol of polar capacitor. Polar capacitor. Usually we represent electrolytic capacitor. Electrolytic capacitor is a kind of capacitor represented in this manner. Electrolytic capacitor. Represented by this symbol. Here, this straight line represent positive sign and the curved line represent a negative terminal. There is one more method by which it can be represented. In a few circuits, you may observe the same represented like this. A straight line for positive terminal and a thick straight line of this kind, a bold line for negative terminal. Yeah, this one represents negative terminal, this one positive terminal. Here I have an electrolytic capacitor. Here you can see minus sign here. This one is the electrolytic capacitor. It is a kind of a polar capacitor. It has got a negative and a positive terminal. As I told you, a capacitor consists of two metal sheets separated by a small distance. The potential difference between these two metal sheets depends on the amount of charge present in the capacitor. I take a Q as the charge, the amount of charge present in a capacitor. Then the voltage or potential difference between the plates of a capacitor will be directly proportional to the amount of charge present in it. Now, I remove this proportionality from this expression. So what I get an equation. To turn this into an equation, I have to include a constant. I include a constant here. This constant is called as proportionality constant. I represent this by a letter C. This proportionality constant is represented by letter C. Here, C is nothing but capacitance. Capacitance of the capacitor. Capacitance of the capacitor. In simple words, capacitance of a capacitor is nothing but the amount of charge a capacitor can hold is referred as capacitance. Here V is the potential difference and Q is the charge. Now from the above expression, from here the value of C can be obtained as the ratio of Q and V. So in simple words we can say that capacitance of a capacitor is nothing but the ratio of amount of charge in a capacitor to the potential difference built between two plates of a capacitor. Now we will deduce the expression for capacitance of a parallel plate capacitor. Before going ahead, let me tell you what is a parallel plate capacitor. Here I have drawn two metal plates separated by a small distance d. When metal sheets or metal plates kept parallel to each other, separated by a small distance d, it constitutes a parallel plate capacitor. One has got a positive charge. Due to electrostatic induction, another plate gets a negative charge. Any capacitor works on the principle of electrostatic induction. As I have told you earlier, principle behind the working of any capacitor is electrostatic induction. In my previous video, I have explained you what is the electrostatic induction. So let's go ahead. Because of the opposite charges in the plates, an electric field is generated here. Electric line of force. Electric field lines travel from positive charge and ends at a negative charge. They travel in this way. This constitutes the electric field E. For a parallel plate capacitor, the electric field is given by the equation sigma upon epsilon naught. Here, sigma is nothing but the charge, surface charge density. Sigma is surface charge density, which is represented as charge per unit area. I repeat, here sigma is surface charge density. That means how many charges are present in a given area of a plate. By keeping these parameters, I am going to find out the capacitance of this capacitor. That is a parallel plate capacitor. We know capacitance of a capacitor C is nothing but the ratio of charge Q and the potential difference between plates. So if we have these two terms, then C value can be obtained easily. Let's do that. Now I have two equations here. Expression for E and expression for sigma. I am going to substitute that I write here. E equals to sigma upon epsilon naught. I take it as equation number 1. And I take this equation as equation 2. Now I substitute 2, equation 2 in 1. What do I get? I get this. E equals to in the place of a sigma upon epsilon naught. In the place of sigma I write this equation, Q upon E. divided by epsilon naught. This can be written in this manner. 1 upon epsilon naught into Q by A. Or this can be written as Q upon epsilon naught A. This is the electric field, the expression for electric field present between these two parallel plates. I box this equation, Q upon epsilon naught A. I take it as equation number 3 for my convenience. Now, to find out the expression for C, I should know what is V. You will learn that the relation between E and V is nothing but potential difference V can be obtained by multiplying electric field with the distance of separation. If you multiply D with E, you get a potential difference. This I take as equation number 4. Now, I substitute equation number 3 in the 4 to get a new expression for V. Now, in the place of V, I write its value. That is Q upon epsilon naught A. That D is kept as such. Then I get this equation, epsilon naught A, which is nothing but V. I box this equation here in this way. V equals to Q D upon epsilon naught A. This is equation number 5. Now, I will substitute equation number 5 in this expression to get the C value. For my convenience, I take this one as equation A. Now, I substitute the equation number 5 in A. Equation A is C equals to Q upon V. Here we know the value of V from equation number 5. So Q is written as such. In the place of V, I write its value as Q D upon epsilon naught A. This can be expanded in this manner. Q into 1 upon Q D upon epsilon naught A. Now, if you take the term present in denominator to the numerator, then we get this expression. It gets inverted. This term will go to numerator and this will remain in denominator. Now the same term present on numerator and denominator get cancel and we get the final expression as epsilon naught A upon D. It is nothing but the expression for capacitance of parallel plate capacitor. This expression that you see here holds good for a parallel plate capacitor with the plates of infinite length. I hope this video is useful. If you have any kind of doubt related to the topic, kindly put your questions in the comment section. Thanks for watching.